This is Mr. Martin. These are the video notes for section 3.8 for Geometry Honors. This is the last section in the chapter. So for this section, we're going to talk about an additional way that we can use to prove triangles congruent. Now, the only thing about this method is that it can only be used for right triangles. So I'm going to mention that again, but be careful. It's called the HL postulate. The H stands for hypotenuse. The L stands for leg. Um, and again, it can only be used for right triangles. So if you have a pair of right triangles and you are having trouble trying to get them congruent because you don't have SSS or SAS or ASA, you may want to look and see if hypotenuse leg will work for them. So the postulate says if there exists a correspondence between two, again I want to stress this, right triangles such that the hypotenuse and one leg of one right triangle are congruent to the corresponding parts of another right triangle, then the two right triangles are congruent. So if you notice, most of our other methods, they use three letters, side, 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 three S's, SAS, two S's, and an A. This one only uses two letters, hypotenuse, leg, and the third piece of information that we need are the right angles. Okay, so again, this is a spot we're going to do things a little bit differently than the book does. So when we use HL in a proof, to get that third piece of information, the angles, we're going to state the angles that are right angles, and then we're going to state the angles are congruent because if angles are right angles, then they're congruent. So you'll see how we do this in the proof, but again, make sure you don't follow the way the book does it because we're going to do it a little bit differently. Okay, and again, right triangles, in case you missed that the first 8 times. All right, so first example, if you want to pause it, feel free and see if you want to work through. I would really recommend for this one that you kind of just follow along and then maybe pause it and try and do the second one on your own. So let's draw our table here. We've got our statements and our reasons, and we're going to put in our given information. We've got BC is perpendicular to AC, so let's take a look and see where that is, BC and AC. So I have a right angle here. We still have to say that, given. And we've got BD perpendicular to AD, given. BD and AD, so that's over here. And we've got that AC is congruent to AD, and that's given. AC and AD. Okay, so you can see right now we have a pair of angles. We still need to get the right angles are congruent, but we can get those congruent, and we have a pair of sides. We also know that this reflexive side is congruent to itself. So with this, you see we have side-side angle. Side-side angle really isn't one of our methods. Okay, so we don't want to use side-side angle. But again, if you notice, we have these right triangles, and we just talked there's a special method reserved just for right triangles if it's usable. You can always use the other methods as well, but we can use hypotenuse leg. So we've got these two sides here. This is our legs. Then we need the hypotenuse, and we can see the hypotenuse is that shared segment, so that's the reflexive property. So we have AB congruent to AB by the reflexive property. And then from steps 1 and 2, I know that angle C and angle D are right angles if segments are perpendicular, then they form right angles. Okay, so if we go back up here, we could see, state that the angles are right angles. and now we're going to state that they're congruent. So now I've got angle C is congruent to angle D. If angles are right angles, then they're congruent. Okay, so here's our legs. This is the hypotenuse. It happens to be the same segment for this. It won't always. And these are my right angles. Okay, so again, we still have 3 steps. We still have these 3 steps. And we're going to still state these 3 numbers in our proof when we get the triangles congruent. So for step 7, we're going to have triangle CAB congruent to triangle DAB. And now our reason is HL. And then we have steps 3, 4, and 6. Okay, so now that we have these 2 triangles congruent, in order to prove that AB has bisected this angle in the corner, I need to show that 1 and 2 are congruent, and I can get those congruent because now they're corresponding parts. So step 8, I've got angle 1 congruent to angle 2. And feel free to always add in numbers to your diagram if you want to make it easier and faster to name angles. And this is by CPCTC. And then step 9, we can state that AB, ray AB, bisects angle CAD if a ray divides an angle into 2 congruent angles, then it bisects the angle. Alright, so there's example 1. Again, we still have these 3 pieces of information here, even though it's only 2 letters here at hypotenuse leg. We still need to get those right angles congruent. Alright, moving on to the next example. Again, feel free to pause the video and see if you want to work this out on your own. This one you should be able to do no problem. If you're going to follow along with me, let's get our given information in there. We've got triangle ABC is isosceles with base BC. Notice how we specify what the base is. Anytime you are given an isosceles triangle, you have to specify the base or specify the vertex angle so you know what the legs are and what you know the base angles are. You need to know what parts are what so you know which sides are congruent, which angles are congruent. And then I've got AD is perpendicular to BC. So we know that these are going to be right angles, and we want to prove that ABD is congruent to ACD. So I know the triangle is isosceles, so I know that these legs are going to be congruent. This is given 3. I've got AB congruent to AC. If a triangle is isosceles, then its legs are congruent. And then since we know that this is perpendicular, I know that angles 1 and 2 are going to be right angles. Angle 1 and angle 2 are right angles if segments are perpendicular, then they form right angles. So now that I know that they're right angles, I know that they're congruent. Angle 1 is congruent to angle 2. If angles are right angles, then they are congruent. So I've got the right angles congruent. I've got the hypotenuse of each congruent. This is the hypotenuse. And there's really no way to get this angle included or this side included between 2 angles, but we notice that we have this reflexive side here. And then again, I've got side-side angle, which we can't use, but since this is a right triangle, it's really hypotenuse leg. So I'm going to put in step 6 is AD congruent to AD by the reflexive property. And there's the hypotenuse. These are my right angles. This is a pair of legs. It's reflexive. So now I have enough to say that triangle ABD is congruent to triangle ACD by hypotenuse leg, and our steps were 3, 5, and 6. All right, so that's pretty much it for this section. One new method for proving triangles congruent if they're right triangles, and again, you still can use the other methods. So um, not every pair of right triangles are going to use HL to prove them congruent, um, but oftentimes you will. So if you get stuck, check and see if you've got the hypotenuse of each, a leg of each, and they're right triangles, and you're good to go. So as always, write down your questions, and we'll see you in class.